Let's try another linear system. Y equals negative 2x plus 1 and y equals negative 2x plus 5. Now in your head you might be thinking, whoa, whoa, whoa. At least I hope you are. We have the same slope. That means something very important. That means that they should be parallel lines. So let's graph it, and you are absolutely right if that's what you're thinking. But let's graph it to see. So our slope here is negative 2 over 1. And my y-intercept is 1. So first I'm going to go up 1, and then slope is down 2 over 1, down 2 over 1, down 2 over 1, and so on. So I connect like that. Now my second one, my slope is negative 2 over 1. My y-intercept is 5. So I'm going to go up 5, 1, 2, 3, 4, 5, and then down 2 over 1, down 2 over 1, down 2 over 1. And I think at this point you should be able to say, aha, just what I was thinking actually comes out to be true. We have parallel lines. You're absolutely right. So in this problem, example 2, they're asking us to solve a linear system. That means find the solution. Well, the solution is anywhere that they cross. Are parallel lines ever going to cross? No, never, ever, ever. So in this case, there is no solution. There is no ordered pair in the entire universe that will ever be where both of these lines cross. So there's no ordered pair we can say that is a solution. So that's a second option. Sometimes you'll get one solution like we saw before when they crisscross. Sometimes you'll get no solutions. All right, our last example is solving this linear system, but here we run into a little bit of a snag because neither of these are in y-intercept form or slope-intercept form, or function form, or y equals form. Officially it's slope-intercept form, but basically what we want to do here is we have to remember to get this as y equals. And there's a bunch of different names for that. So I'm going to take my first equation, 2x minus y equals negative 3. I'm going to subtract 2x on both sides to get my y by itself. Negative y comes down, I get negative 2x minus 3. This is really a negative 1y. I don't want negative 1y, I want positive 1y. So I divide by negative 1, divide by negative 1, divide by negative 1. Y is equal to 2x. Negative divided by negative cancel out just like they did over here, and I get plus 3. So these negatives canceled, I got positive 2. These negatives cancel, I get positive 3. Here's my equation. So let's go ahead and graph 2 over 1, 3. So I'm going to go up 3, and then up 2 over 1. Or down 2, but to the left 1. It's if I were to do a negative, negative. This is the same thing as a positive. So here's my first equation's graph. Okie dokie. Let's try the second one. Second one is negative 4x plus 2y equals 6. Excuse me. So I'm going to add 4x to both sides. I get 2y equals 4x plus 6. Divide everything by 2 to get that y by itself. Y is equal to 2x plus 3. Oh my goodness, we have exactly the same equation. So if I plot it, I will get exactly the same thing. Up 3, then up 2 over 1. All of these points fall on the same line because it is exactly the same line. So in this case, where are they intersecting? Where do these two lines intersect? Where does this line intersect with this line? Everywhere. So our solution set here, our solution would be all solutions, or better said, infinite solutions. Go with that one. Infinite solutions because there's an infinite number of points that fall on this line. It's basically any point that falls on the red line is also going to fall on the blue line. So there's an infinite number of them. So in closing, we have three things. We could have a graph. We have three different cases. Let me draw these. We could have a graph where two lines intersect, and whatever that intersection point is our one solution, and we have to label what that one solution is, and we should check it to make sure it works. We could have graphs where we have parallel lines. In this case, it's no solution for our system. And we could have graphs where we graph it and it's exactly the same line, meaning we have infinite solutions. So those are the three cases you can get. So now you can go ahead and graph some systems and see what you find out. Good job, guys.